So now before going any further, let's actually first attempt a question based upon the logic which we have just heard. So we are actually asked to mark the points mentioned over here. So 4 points are given to us. So the task is to actually mark these 4 points and mention their quadrants. So we'll just start with the basic understanding of the quadrants which we have just heard a minute ago. So the first point was 8, 3. So we don't have to actually measure the exact distance. We just need to understand that what is being talked about. So over here the point was 8, 3, which we can clearly sense that it is 8 along the x-axis and similarly 3 along the y-axis. So 8 horizontally but on the right side and 3 then vertically. So 8 here and then 3 here. So in a way we have to just notice the point 8 at let's say 8 boxes over here and 3 over here. So somewhere here would be this point 8, 3. So this was the first point that was to be marked. Next comes minus 6, minus 4. So we can see that minus 6 means we have to move left hand side from the origin at a distance of 6. 6 left hand side and similarly 4 down. So over here would be minus 6, minus 4. This was the second point. Next was 2, minus 5, which means 2 on the right side and 5 down. So somewhere here it would be 2, minus 5. I'm not going specifically by the distances. For this question. The main task is to make you understand the location of the quadrants. So that's why I'm not going much into the depth of distances. Next is minus 9, 10. So minus 9 means we have to move on the left side and 10 means upwards. So somewhere here it would be minus 9, 10. So this point is in the first quadrant. This point we can see is in the second quadrant. This is the third quadrant point, minus 6, minus 4, and this is the fourth quadrant. So these are the 4 points and we have just marked them. So now let's attempt a question exactly based upon this logic by ourselves. So the main task in math is not to only listen. Only listening is actually the most basic part. The main task is doing the questions by yourself. And since I would be there for any kind of hand holding, so after attempting we would be discussing those questions as well. So now just after this, as a question is going to appear on your screen, you have to solve it by yourself and then we'll discuss that question again. So now we have just solved this question and it was a very simple one. We can see that in the same manner in which we have solved the last question, 6, 7 was in the first quadrant, somewhere here. So if we have marked it somewhere here, we don't need to worry about the distances and all that stuff, but we know the process. 6 means we have to move horizontally 6 and 7 means we have to go vertically 7. X comes first, horizontal, vertical. So this point is in the first quadrant. Similarly, minus 4, minus 10. Minus 4 means this side and minus 10 means this side. So it's somewhere here, minus 4, minus 10. Minus 4, minus 10, it's somewhere here. Next is 8, minus 3, which is 8 on the right, which means on the right side, positive side, and minus 3 means down. So somewhere here it would be 8, minus 3. And similarly minus 5, 6 would be somewhere here. Minus 5, 6. So this point was in the first quadrant. This point was in the third quadrant. This in the fourth quadrant. And this one was in the second quadrant. So if you have marked these points correctly, so this was the first task. So we have learned something new today and we have implemented it by ourselves. So now let's move to the first very easy formula. First we'll actually understand that how that formula is created and then we'll actually move to questions related to that formula. So let's start by the very basic understanding. So now we are going to discuss the first formula, which is very simple, but first we'll understand that how this formula is formed. So the formula which we are going to create by ourselves right now is how to find the distance between 2 points in this plane, in this two-dimensional plane. So over here I'll use another name which I haven't used earlier. That is this plane. The plane which I am referring to is known as the Cartesian plane. Just keep this name in your mind. Nobody is going to ask you to go into much of detail of this name, but this is something which you will just see for so many times. This two-dimensional plane which we have marked in the form of x-axis and y-axis, that the topic is obviously coordinate geometry, but this two-dimensional plane is known as the Cartesian plane. So in a x and y-axis plane, which is the Cartesian plane, and someone asks me to find the distance between 2 points over there. Like for example, we can see in this figure that 2 points are marked. One point is over here. Let us assume that this point is x, which is denoted by the point x1, y1, and similarly the other point is in any quadrant, but that point is x2, y2. Look, in this example, in this picture, it seems like both these points are in the first quadrant, but it is not true. These 2 points can be anywhere on the Cartesian plane. One point is in the fourth quadrant and the second point is in the second quadrant. It is a valid formula. So if we have to find the distance between 2 points, so what's the logic? If we just try to understand a very basic proposition, for example, if I move from this point horizontally, I'm just going horizontally. So if I am moving horizontally, I can clearly assume that my height would remain the same since I am moving horizontally, and height is represented by this y coordinate. This is the height, this is the vertical rise. So y coordinate would remain the same. What would change? Only the x coordinate when I am moving horizontally. So let us assume that on moving horizontally, I ultimately just come just below this point, So when I am just below this point, then obviously the x coordinate would be same as the x coordinate of this point. X coordinate, since my horizontal distance is the same as of this point. So x coordinate would become from x1, it would now be x2. So when I am moving just horizontally, so this point's x coordinate would be x2 from x1, since it's just below this. So it means that the distance horizontally traveled is the same as this one, but the y coordinate would be this height. So we can see that this point would be x2, y1. So this point would be x2, y1. So how much distance we have traveled? Simply horizontal distance traveling. Y coordinate is the same. We haven't done anything on the vertical side, but horizontally we have moved this much of distance. We can see that this is x2 and this is x1. So this horizontal distance is x2 minus x1. This horizontal distance, simple horizontal distance, is x2 minus x1. Earlier it was x1, now we have moved to x2. So how much is this distance? This is x2 minus x1. Similarly, if we go by the same logic but vertically now, we can clearly see that this distance would be y2 minus y1. This vertical distance would be y2 minus y1. And we can see that a triangle is formed over here. So in this triangle, if we directly apply to this triangle, if we directly apply Pythagoras theorem, we can see that this is a right angle triangle. So in a right angle triangle, we know that this is A, this is B, and this is C. We know that C square is equal to A square plus B square. So we'll directly apply the Pythagoras theorem over here. So we can clearly see that this distance which has been asked for, this distance, is actually the hypotenuse of this triangle. So this would be represented by directly C. So C square means this distance, the square of this distance. Let us assume that this distance is D. Then D square would be equal to A square plus B square. A square means x2 minus x1 whole square, and B square means y2 minus y1 whole square. So just now, by our basic understanding, we have actually created the formula for distance between 2 points. The distance between 2 points, if represented by d, then its square would be equal to this. So it means d would be equal to, directly we can see that d would be equal to, let's write it over here. So d would be equal to x2 minus x1 whole square plus y2 minus y1 whole square, the square root of it. So this is the formula which you have to just keep in your mind always.